Good evening, guys. Let us start with the new seminar, new workshop, new contents on DevOps. Hopefully, everyone is looking for this word because this is really in boom. Everyone knows that DevOps is required everywhere, but many people are a bit confused about what exactly do you mean by DevOps. That is the reason why we have arranged this a very small session where you can see what exactly DevOps is, and if you are having some confusions, we can get them clear. So let me introduce myself first, and then we'll start with the actual content. My name is Amit. I'm having a decade of experience in both teaching as well as development. I'm here in SunBeam working as an associate technical director. Other than that, I'm also a freelance developer, developing many applications with a variety of technologies. Not only in mobile, I also work in web development as well. Now, starting from 2009, I have developed more than 180 applications on mobile for iOS and Android, and all of them are already there in Play Store and App Store. Other than this, I already have developed many websites in multiple stacks. You might have heard about PHP, LAMP, or Mean, or Moon. I've developed all these applications along these years. Recently, I got certified with the Jenkins. What is the Jenkins? I'm going to mention that later today. So stick to it and you will see what exactly Jenkins is. So these days, when I'm working with the real clients, I mean, as I said, I'm a freelance developer. I'm working with the various different live clients, and those clients are coming up with their requirement, and I really develop the applications for them. Now, these days, when the clients are coming, they are having simple goals in their mind. They want to get their application done as quickly as possible. Now, unfortunately, when we are trying to see the history of many years before, people started using something called as SDLC, and they were following something called as a waterfall model. Now, clients in those areas or in those days were having a different mindset. Today, client wants to get that application developed as soon as possible, and that is the reason why these are the old or deprecated technologies. That is the reason why we have to start with the latest one. The latest one today is something called as a DevOps. So what is a DevOps? That is what we are going to see today. Let me quickly go through what is the agenda today, so you will understand what exactly the contents we are going to see, and then we'll start with the actual thing. So we know that SDLC is something which is quite old, and that is the reason why we are going to skim over it, and we'll understand what do you mean by SDLC. Almost all of us are developers, and we know that SDLC stands for Software Development Lifecycle. One of the implementations of software development is called as waterfall model. So this is what we are going to see with the implementation as such. What is a waterfall model? Why it is kind of deprecated these days, and why people are looking at the DevOps. Now, once we understood what is SDLC and waterfall model, we'll start digging down into the DevOps world. We'll understand what is DevOps, why DevOps, and what exactly and where exactly you can use these DevOps tools. Once we get to know what exactly the DevOps is, we'll look at the most important part in DevOps, which is called as a DevOps lifecycle. So what is the DevOps lifecycle? What are the different stages there? What exactly the stages are doing? What are the implications of those stages in your practical day-to-day development? All sort of these things we are going to see in that part. Now, once we know what exactly the DevOps lifecycle is, you will be kind of getting familiar to it, and you will be kind of pretty comfortable with the definitions, where it can be used, and so on and so forth. Now, probably most of you want to switch their career to DevOps engineer, and that is the reason why we have included one more section to understand if you want to go for a DevOps engineer job, what are the different skill set you need, and what are the different responsibilities you have to carry in the day-to-day environment. Finally, once we are done with the entire discussion, we'll have maybe some time reserved for question and answers. There we'll try to answer all the questions you are going to put on your Facebook. So basically, if you have any question, go ahead and put them on that web page. I'll go through all these questions one by one once we are done with this. Okay, let us not spend more time on this, and let us start with the actual content. So let's begin our session today. Because SDLC is the most important part, I cannot directly start with the DevOps. So let us see what exactly the SDLC means. So what is SDLC? Everyone knows SDLC is something called as a software development lifecycle. Now, what do you mean by that? Now, generally, when the client comes with you, asking you whether you are available, whether you can develop the application for him, he will come back with his own idea. Now, sometimes people say, I want to develop an X application. Will you be able to develop that application for me? Now, when the client is having an idea, we have to ask that question to the client, right questions to the client, and we have to get the requirement. Once we understand the requirement, we have to design it, and then we have to implement it, we have to test it, and we have to deploy it. All these are continuous stages. Like first we have to get the requirement, we have to understand it, we have to plan it, we have to design it, and so on and so forth. All this, they have kind of standardized them into a life cycle called as SDLC, which has these different stages. The very first stage is called as the planning. Now, in this stage, generally, we go ahead and we ask the right question to the client, and we'll see what exactly client is looking for. Generally, client doesn't know what exactly is looking for. He just has only one line of description. I need an application which can do blah, 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 blah. There we have to ask the kind of questions that will give us the insight about the idea. We have to get the real information and the right information so that it will be easy for us to define the final requirement. Unless you define your requirement, unless you get them approved from your client, you generally do not start designing. So in the first phase, planning and defining, these are the two important stages. Unless they are done, you cannot just start working on the project. Once your requirements are finalized, once your requirements are frozen, we'll go to designing phase. Now, what is the designing? The designing is where we have to decide the architecture, we have to decide the language, we have to design the database if it requires any. And then once everything is ready, we'll get a complete picture. Like this application can be developed by using mean technology, or this application can be developed by using a LAMP stack, and so on and so forth. Then we'll go with the different design patterns, and we'll start creating an application architecture. This is called as a designing of your application. Now, once the application is designed, this is the real stage where we start writing the code, where you and me, like developers, are involved, and there we have to start writing the code by using different languages. Language like C, C++, PHP, Java, and there are a number of languages. You are aware about that. So this is the main stage where we start building the application, where we start writing the code in the application. Once the application is ready, once the application is having all the features, we'll start testing the application. Of course, no one wants to put the application in the app store, or no one wants to put the website in production environment and get the responses from client that application is not working or website is crashing, something sort of that. This is so humiliating for a developer. So a company even doesn't want to get these kind of comments from clients, and that's the reason why company after development will focus on the testing phase as well. In a sense, when your application is done, company wants to see whether your application is up to the mark, whether it is performing well, whether it is sticking to the application requirement, and so on and so forth. So basically, when the application development or application building is done, we go to the testing and we'll make sure that the application is working well. Once we pass this phase, we go to the final stage. This is called as deployment. Now, the deployment is where you want your application to be available to the end user. Naturally, if you're developing a website and if you're running this application on your machine, you can access it, but your clients will not be able to do that. So after you are done with your development, after you are done with your testing, you want your application to be available to their end users. And to do this, we generally go ahead and deploy our application to various different ways. For example, we may deploy this in cloud. For example, if it is a website, I can put that on my EC2 instance on AWS. Or if it is a website, if it is a mobile application, let's say if it is an iOS application, I can send it to App Store. If it is an Android application, I can put that in Play Store so that my end users will be able to access them. So finally, when we are done with this stage, we are kind of done with the requirement. So this is maybe a cloud, or this is something like App Store. So there are a number of ways where how you can make your application available to the end user. So this is generally called as SDLC. SDLC, it's a software development lifecycle, and this will help us to standardize the process of developing application. There are 6 phases, starting with planning. Let me just go back and quickly skim over those stages. Planning, where we start getting the requirement from client, we analyze them, and then we go to the defining stage. Defining is the stage where we are kind of finalizing the requirement. Once the requirements are finalized, we go to the designing stage where we decide the architecture, we design the database, and once that is over, looking at the design, we start building the application. Once the application is built, we start testing the application just to make sure that there is no bug and there are no gap in between the maybe requirements given by the client and the application you have developed. And finally, once everything is okay, you put your application into market or you put them in the cloud to make sure that your clients, your end users can access it. This is generally called as software development lifecycle. Now, when you're talking about a software development lifecycle, there are various different models which are implementing this SDLC. One of the oldest models is something called as a waterfall. Now, what is a waterfall? This is called as a waterfall because you can see here, there are different stages. Stages like the requirement specification or maybe the system design and so on and so forth. If you see here, all these stages are coming one after another. Like when the requirement specification is done, we are going to the next stage, or when the system designing is done, we are going to the next stage, like next stage, and so on and so forth. It feels like the water is kind of dropping from the top to the bottom position. And you know that water does not go from bottom to top, it always comes from top to bottom. And that is the reason why this model is called as a waterfall model. A waterfall-like structure will give you an idea about the different stages in your development life cycle where you can implement them and make sure that your application is getting to the client in as quickly as possible manner. I mean, when you're talking about something like a waterfall model, gone are those days we are using this, but still, if you're looking at a waterfall-like model, this is the oldest model. So when you think about the waterfall, the main idea behind it is like you decide the whole application. So this is my application, for example, and you get entire requirement for the application. So this is where the requirement specification comes into picture. When you're talking about a requirement analysis or requirement specification, you get the requirement from the client, you analyze them, and then you finally specify them. I'm going to do blah, 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 blah. Once everything is specified, once you get the client's approval, you go to the next stage, the client design, system design. Again, the design is nothing but where you are going to decide the architecture, where you're going to design your database and stuff like that. When you're talking about these stages, please keep one thing in your mind. You're talking about entire application as a whole. In a sense, if the application is large enough or if it is a huge, it is going to take years to develop it. And when you're saying it is going to take years, all these stages have to be followed one after another to finalize or to finish the entire application as a whole. Once the application's design is finalized, we simply go ahead and we start writing the code. That is again the coding or design implementation. Of course, like last time I said, you cannot just put the buggy application into the production. So you will verify it and you test it. Make sure that there is no issue, there is no bug, and there are no gaps between your application and the requirement specification. Once everything is tested well, you simply go ahead and make your application available to the end user, and that is the system deployment. And finally, if the application is going into the end user's hand, of course, end user will have some requirements, some new suggestions, new feature to be implemented. They will also find some bugs, those requirements, those new features, we need to add them into the application under the software maintenance. Now, imagine that you are looking at the entire application here. Now, tomorrow, if your client says, I want to modify something, you can't do that because you already are into waterfall model. And when you're saying you are in the waterfall model, every stage is coming after the previous stage is done. I mean, you can't just go back from here to here. You can't just go back here to here. So in this case, when you're talking about something like the waterfall, the biggest problem of the waterfall is like you can't go back and you can't fix the previous stage immediately. For example, you are in the system deployment phase right now. You already have deployed the application, and then your client says, "Hey, I mean that page looks okay, but I want to modify something here. Can you do that?" Of course, we can, but it's not like we are going to directly come here and we implement this and then we can deploy the new changes. This is not going to happen. When you're talking about the waterfall model, unfortunately, you have to again go back to stage one, and then you will come back again, the requirement analysis, system design, system implementation, system, or maybe the coding, verification, testing, and then you will go for the final deployment, which means it takes a hell lot of time to develop an application following this waterfall model. Okay, so this is the main drawback of waterfall model. Keep this in your mind. I'm going to need that later when we start with the DevOps. So when you're developing the applications, let me see what are different entities which are required here, or what are different entities which take part in this particular model. No matter which model you are using, software development requires these kind of entities. When I say entities, those are the people who are involved in this particular lifecycle environment. So for example, the one who is going to develop the application, we generally call that person as a developer. We know that the developer is a person who develops the application. Of course, developer follows all the system designs, which we already have finalized in the previous step, and developer simply uses different languages like C, C++, and there are a number of languages, and develop the application. Application cannot be sent to the production environment unless it is tested well, and that is the reason there is another entity, there is another set of developers, called as a testers. They are involved in making sure the application is working very well. See, earlier, I mean, back then, people were having two different categories of developers, like a developer and a tester. These days, we are calling this team, I mean, this is a team, and we're calling these two kind of users as a one team, and we call it as a developer. So back then, we were having a developer separate and tester separate. These days, we are saying developer, and when I say developer, developer has a two set of users, or two set of maybe employees, you can say. One is the developer himself, the one who is going to develop the code, and the other one who is going to test the application, that is a tester. So henceforth, when I say developer, please understand this, I'm referring to both of them, developer plus tester. So henceforth, there is no different, you can say, employees in your company, developer and tester. Both of them are under one single umbrella called as a developer. Fine. So you need a developer to develop the application. You need a tester to test the application. What else? Once the application is tested, you want to put that in a production environment. Now, whose responsibility is it? Is it the responsibility of a developer or a tester? Good news is none of them are going to do this job, because generally in the company, there is a separated team who is going to take care of all the resources that you are going to need. For example, you might need some servers. You see, there are some servers required, or you want to move your application from your machine to the server. Of course, there are people there in the companies, and we call them as operations team members. So this is the team which is responsible for managing all the resources that you need. Whether you need some networking solutions, whether you need some networking assistant, or maybe there is some some problem with your logins and stuff like that, those people will give the maintenance. If you need some cloud services, tomorrow if I want to go to AWS and create an EC2 instance, am I supposed to do that? Of course not. There is a team operations who is going to give me that all the resources required for my infrastructure or for my deployment. So all this infrastructure management will be handled by another team known as operations team. So there are two types of teams these days. We are having a developer team and we are having an operations teams. Both of them are having their own responsibilities. Responsibilities like this. The developer and testers, we are calling them as a developers team now, where the developers are going to develop the application naturally. They are going to package the application. Now, when I say package, that means you are going to compile your application, build the application, and create a final deployable package. Now, when I say package, for example, you must have at least installed once in a lifetime Android application. And if you have done that, you might have noticed that the Android application comes in a .apk format. So this APK is nothing but the package, Android package. When you talk about something like iOS application, you can say this is something called as the IPA format. iPhone application, iPad application, iPod application. It's called as IPA package. Both of them are something called as the packages. Whose responsibility it is? It's a responsibility of a developer to create the final package. Of course, if the tester is reporting some bugs, you have to fix it being a developer. So it's a responsibility of a developer. And finally, maintain the application by adding the new features suggested by the client. So developer is performing all these responsibilities. What about the tester? Naturally, tester's job is to thoroughly test the application. Make sure that the application is working well. Make sure that the application is not crashing. Make sure that the application is performing well in various different conditions. This is the tester's job. How will tester do it? It's up to him whether the tester wants to go for a manual testing, black box testing, automated, white box testing, gray box testing. There are a number of testing methodologies out there. So that's a tester's headache. But tester is responsible for testing the application and making sure everything is working well. Of course, if the tester finds any bug, it is a responsibility of a tester to report it back to the developer and let the developer know why the bug is there, what are the different stages which we need to fix the or reproduce the issue so that the developer can reproduce and fix the problem. When you talk about the operations team's main job is to make all the resources available, make all the resources ready. You need an infrastructure, no problem. Operations teams can give you. You need to deploy the application, no problem. Operations team is there to deploy the application. You're not going to do yourself. Of course, they have to maintain the multiple environments. Generally, in the company, when you are developing the application, you don't want to put that application into production before you test it very well. So generally, when you talk about the multiple environments, there are multiple environments. Like the one which you are developing on your machine, we call it as a dev environment. Then there is a test environment. Then there is a staging environment. And finally, there is a production environment. All of them, I'll say product or production. So all of these environments management will be handled by the operations team. Operations team is responsible for that. Very important. When the application is available in the production environment, it is the job of operations team to continuously monitor whether the application is running well, whether it is getting all the resources it is looking for, whether it is not crashing and stuff like that, which is generally called as monitoring the application. And finally, if the resource is failing, if the resource requires some kind of upgradation, that's managing a resources, again, is the responsibility of operations team. Now, when you're talking about this, probably you can see that there are many challenges they face. The challenges are like developers' job to develop the application and make the application available to the tester. The process is very slow. Sometimes it takes a couple of weeks, sometimes it takes a couple of months, sometimes it takes a couple of years, depending on how huge the project is. Not right now, but earlier when we were using the waterfall model, that was the problem, that was the challenge that people were facing. Because of the pressure to work on the newer feature and fix the older code, if the tester has reported the bug, then it becomes very difficult for a developer to understand what he has done a couple of months before and go into that mode and fix the problem. So again, that was one of the challenges the developers were facing earlier. And of course, this process was not flexible. So these are the challenges that developers and testers were facing earlier. What about operations team? Operations team was finding it very difficult to maintain the uptime of your resources. Of course, configuring the huge infrastructure was again one headache. Now, when you are having one or two machines, it becomes very simple to go ahead and configure every single thing manually. But imagine when you are going for an application development like, let's say, Facebook or let's say Netflix. They are using not thousands, millions of containers out there. It becomes very impossible to go ahead and manually configure these things. So management of your infrastructure, it becomes one of the great challenges of operations. And of course, they needed to do that manually earlier. Again, diagnose and fix the issues related to the resources was one of the challenges people were facing earlier. So what did they do then? They tried to kind of minimize the gap by introducing something called as agile development. Did you see something last time? When I say waterfall, I said that it was a painstaking process. In a sense, it was taking sometimes couple of months, couple of years as well to develop the entire process. So agile development tried to bring the gap or tried to minimize the gap between the developers and the operations by reducing or by splitting your entire process or your entire applications into smaller tasks. So that is the credit the agile development is taking these days. Of course, it has to take that credit. Because of that, your development is kind of making the lives bit easier. And whose life? Developers' life bit easier. And not only developers, operations team's life also easier. How? I'll explain that in a second. So again, when you talk about the agile development, it is similar to waterfall, but instead of thinking the application as a whole, it kind of goes in different iterations. Again, the phases names are almost similar to the last time. Like there is a planning phase, there is a designing phase. You can see that. There is a designing phase, there is a development phase, there is a testing phase, there is a release phase, and you have to again listen to the customer's feedback and again integrate that into the next part. Now, when you talk about something like this, when you talk about something like the agile development, these are the similar phases, but we are not implementing them on the entire application. We are dividing the applications into smaller tasks. So there will be multiple tasks out there. So for example, one application is kind of splitted into, let's say, 3 tasks here. Then we decide, okay, let's finish the first task, then let's finish the second task, and then let's finish the third task to achieve the target. So when I say something like the planning or designing or the development, all of them are with respect to small, you can say the functionality of your application, not the entire application as a whole. In waterfall model, we were looking at the whole application at a time, and that was the reason why it was taking a couple of years to get the application in the end user's hand. But these days, because of the agile development, the process has come down to few weeks, not in months, but at least in few weeks. So that when the client wants to get the application developed as quickly as possible, you as a developer can finish some part of the application, deliver to the client, and client will see what exactly is going on. Earlier, back then, client was not able to see anything till the entire application was getting developed. It was so frustrating for a client to see or to literally sit quiet for almost like a year or two. And then finally, once he sees the application, there were so many issues, there were so many bugs, there were so many suggestions. And again, the process was taking so much of time. These days, we're not going through this kind of headache. We are going through something called as agile development. And agile development is kind of breaking your application into smaller tasks. Okay, so to carry this out, we are using the processes. And one of the famous processes is something called as a Scrum. You might have heard about that. A Scrum is like when I say there are multiple tasks, you're going to finish all of those tasks at once. You club all those tasks into different sprints. Sprint, you can think of it as a collection of different tasks. And then we start talking about one sprint at a time. We, out of let's say 100 tasks, I'll decide, let's take the first 10 tasks. We create a sprint. We again perform all these stages. We plan for that sprint. We maybe design for that sprint. We code for that sprint. We test for that sprint. We release that, and then we'll listen to the feedback coming from the client. So when we start something like a sprint, this is per, you can say this is per task. So out of 100, if I've taken 10 tasks, I'm going to do all this task, and then I'll literally execute all these phases for these tasks, and then I'll pass on whatever I've done to the client. This is generally called as a Scrum. I'm not going into too much of details of it right now because it's not so important. The important fact here is because of the processes like Scrum or something called as a Kanban, it becomes very easy for a client to see what exactly is happening. Otherwise, with waterfall-like model, it was impossible for a client to see what is happening, maybe almost like years, maybe years or 2 years. These days, client can see what exactly is happening in the real time. That is the advantage of using the agile development or one of the implementation of agile development called as a Scrum. Okay, so basically, this is all about the agile development. Now, when you talk about the agile, let me quickly compare what exactly the waterfall model and agile model, if I put them side by side, what exactly they can differentiate in between. You can see here in waterfall process and waterfall model, we see the entire application as a whole. We plan, we design, we code, we test, we deploy, we maintain all of these stages for entire application. And that is the reason sometimes looking at the whole application, the developer gets confused. This project has got so big. Looking at the project, you can see that it's so big project, and developer might think, oh, I'm not sure whether I'll be able to deliver it on time. This was the case earlier because we were looking at the entire application at once. You see, we are designing it only once, we are coding it only once for the entire application, we are testing it only once for entire application, and we are deploying the entire application in the user's hand or in the client's hand. Now it is changed. Now we are not using this. We are using something like the agile process. What is agile? Agile is the way where we are splitting the entire application into smaller tasks. Think about them as a smaller task, and you see here the developer is going to work on one or maybe multiple of tasks at a time. You see, this particular symbol reminds me the Apple symbol, isn't it? Anyways, so when you talk about something like this, the developer will look at the smaller task, not as a whole as application. So it becomes very simple for a developer to finish a job as quickly as possible. So for a developer, it is so much better delivering this project in the bite-sized section. So a developer can chew what he can chew at a time, not the entire application will be started and will be left in between. That is the advantage of using Agile. Now, when you're talking about the Agile, let's look at these two stages here. This is pure Agile. Maybe I'll say this is pure Agile. In Agile, we develop the application, we code the application, not application, we develop for a particular sprint, we test that sprint, and we kind of look at the, or we start with the next sprint. The entire application will be developed, towards the end of it. But again, this was the older methodology, not these days. We are doing a kind of advanced version, or you can say modified version of Agile. This is called as Agile, the one which we are following these days, plus continuous delivery. Now, what is a continuous delivery or continuous deployment? Look at this. Here, we design for a particular sprint. We code for a particular sprint. We test that sprint, or we test those functionalities, and then we immediately deploy that application to the client. So the client will see what exactly is going on, and by the time I'll think about the next functionality, I'll start coding the next functionality, I'll start testing the next functionality, and I start delivering the next functionality, and this cycle will continue till the end of your application. So you see, the development cycle, I mean, it was a kind of a long process. Now it is kind of splitted into smaller parts. And that is why the clients are getting the updates quickly, and they are getting the, I mean, they can see what exactly is going on. That is the advantage of using the Agile. But how do you achieve it? I mean, I see that it is a continuous deployment, continuous delivery, but how do we do that? We can't do it without the help of something called as DevOps. And here is your DevOps. So what is the DevOps then? The DevOps is like bringing the developers and operations people together. We want them to work in collaborative fashion so that they can develop and they can deploy the applications as quickly as possible. Have you not seen it here? You see, we have to deploy the application, and developer has to get freed so that he can start thinking about the next sprint. Again, the process need to restart for every single sprint. And if you want this to happen, you have to have the DevOps in the picture. You have to automate these things by using different tools. And that is the job of DevOps. So what is a DevOps? A DevOps is the software development strategy, like what we were following last time as Waterfall, which brings the gap between the developers and the operations side of the company. So we are breaching, or we are kind of, bringing the gap towards, maybe you can say we are zeroing it out. But please remember again, when I say dev here, there are two teams here. One is the actual development team, and the other one is the testers team. So there is a dev and there is a test. We call both of them together as a kind of developer. Okay, now if it is a DevOps, which is going to help me to bring those gaps in between, or maybe we can, you can say, loosen that gap. If I want to do it, how can we do that? See, this picture will give you the clarity about what exactly the DevOps means. Okay, so as a DevOps, you can see there are two words, developers and operations. Let us see here. Please again keep one thing in mind. When I say developer, developer is equals to developer plus tester. Okay. Now imagine that when developer wants to start developing the application, the developer has to first plan what he is going to do. So this is the first phase called as a planning. So developer will say, okay, I'm going to finish blah, 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 blah steps. Fine. So once the developer has planned, the developer has to develop the application. And when I say develop the application, developer has to code the application, isn't it? So there he has to start writing the code. Maybe I'll say this is the second stage where the developer is going to start building the application. So developer start writing the code. Now, once the code is there, once the code is ready, we want to package it. To package it, we have to build the application. So this is the next stage where we are going to build the application. Now, when I say build the application, please remember building means compiling your application to executable and packaging your application to create one single deployable package. Now, once the build is over or once the build is ready, you don't want to directly pass it on to the production environment. You want to first test it. And that's what I said. Developer is equals to developer plus tester. So here, right after the build is ready, we want that application to be tested. So this is the next stage called as a test. Okay, next what? Once the application is well tested, you want to pass it on to the operations team so that operations team can deploy your application. So this is where the release phase comes into picture. So this is the release phase. Sometimes this phase is also called as an integration or integrate phase. So this is the integrate phase. Again, you see, after test, we are kind of, passing it on to the operations people. So operations people can simply put that on the final production environment. So this is called as a release. Once the release is done, I mean, once you are kind of through with this process, the operations people will simply deploy the application. Okay, so basically this is how we are going to deploy the application. Okay, let's see. So this is the operations people job, is to deploy the application. Again, once the deployment is over, we want, or the operations people want that application to get operated with a different criteria. So this is the next step. This is called as the operate. This is another stage called as operate. Now, once the application is getting operated for, let's say, a couple of days or a couple of hours, for example. So the operations team can see what exactly is going on with that application, whether the application is failing, whether the application is getting the right amount of resources, and so on and so forth. And this is where the monitoring is required. So this is something called as the monitor. So this is the monitoring part. Now, see, when you are doing this, or when the system operations are doing the monitoring, the operation, and the deployment, the developers will not sit quiet, isn't it? The developer will start thinking about the next sprint, meaning after the continuation or after the monitoring, we have to again go back and not like this, but we have to go back and start planning for the next stage or planning for the next sprint. Oh, can you see something here? I can see something. Look at that. This is nothing but the same infinity symbol you must have seen many a times when people call it as a DevOps. You see, this is called as a DevOps, where we are executing your application development into different stages, and we are executing those stages one after another. Very quickly, we start with the planning. We go to the code where we build the application or where we code the application. Build means literally compiling your application and creating the deployable package. We test the application, and once the application is well tested, we want that application to be deployed by using a release of functionality. Release means your application has been passed through all the tests and the application is not failing. That's the main point to remember. Once the application is deployed, you want that application to get operated in a couple of hours, a couple of days to see whether it is working very well. And then you start monitoring the application. Once the application is monitored properly, the operations system or the operations team will come back with the report, like the application is maybe looking for some more resources so that they can upgrade their environment and stuff like that. Again, by the time you go ahead and you work or you plan for the next stage, and this will continue to happen till the end of your application. And that is the reason that infinity symbol is used to represent the same. This infinity means it's a continuous process. So what is a DevOps then? A DevOps is a continuous process of getting your application developed without having any problem. Now, tell me one thing, like if you want that to happen, isn't it so obvious that we have to kind of automate this process? Because think about this, if the developer wants to code, developer wants to build, developer wants to test, developer wants to release, developer wants to go ahead and ask the operations people to deploy, it will take a lot of time. And you see, our main achievement or our main goal here is to reduce the amount of time requires to finish the application. So we don't want developer to do something which he is not looking for, he should not do. For example, the developer should not worry about how the application is getting built or how the application is getting tested. So he should worry about only his job. So it's so obvious that if you want this to achieve, there has to be some kind of automation. Okay, so if there is some kind of automation, how well we're doing it? And that is what the DevOps is telling us. So this diagram which I just showed you here, you generally have seen something like this. So DevOps is telling us we have to go ahead and try to automate all these stages so that you can work on one stage and the other stage will automatically get done. You don't have to wait for it. So it's so obvious that when you're doing something in sequence, it will take more time. If you're doing that in parallel, of course, the speed will be increased. And that is the reason why DevOps can deliver the application in so much less time compared to the waterfall model. Okay, wonderful. But how do we do that? We have to do it by following all these stages one after another. Okay, let's go through each of these one by one. Let us start with the very first stage called as a plan. What is a plan phase? Now the plan phase is exactly similar to the planning phase in the waterfall model or planning phase in the SDLC, where we start asking the question, right type of question to the client. We get the answer, we get the requirement, we analyze them, and we start finalizing all the kind of requirements the client is looking for. Now, of course, when I say we have to ask the right amount of questions and we have to get a requirement, I'm not talking about a system as a whole or application as a whole. I'm talking about only that part of the application which you want to go ahead and finish it off. So that is the plan. How do you do that? To do this, there are many applications out there. For example, there is something like Jira. You might have heard about that, Atlassian Jira. There is a box service out there. If you want to share your contents or if you want to see what exactly is going on, you can go for the Google Drive, for example, or you can go ahead and use something like a Dropbox, or you can go for something called as a Trello, and there are many other tools available. I'm not saying like you have to use them, but just giving you a suggestion. Like you can use any one of them and you can start putting all those tasks which I mentioned earlier. You break down your application into different tasks and you start thinking about one task or one sprint at a time, and you go for planning a particular sprint. So this is the plan phase. We are not again considering the entire application as a whole. We are looking at only a few tasks combined together to create something called as a sprint. Okay, so when we talk about something like this, probably you can see here. So now when you talk about the plan, we are talking about planning only that particular module or that particular sprint. That's it. We're not talking about the system as a whole. Fine, then what? Then probably when you're talking about something like the plan, once the planning is over, we want to go ahead and we want to start coding the application. Now again, when I say coding, we are not going to talk about the entire application as a whole. We are talking about simply kind of coding only that part of the code which is kind of decided in that particular sprint. Fine. How do we do that? We need some kind of tools here. The tools which are something called as the IDE. Of course, when you want to develop the application, we have to use the IDEs to simplify our life. So basically, we can use IDEs like PyCharm, let's say for Python, or Visual Studio Code, or simply Visual Studio for different languages, Eclipse. We are going to use something called as source code management tools like Git or like SVN, and there is something called as a Webpack or something called as a NPM. These kind of package managers. Did I mention something about creating the package? Yep. We are going to use something called as a package managers, which will provide us kind of different modules required for our development. Now again, once the code is over, once the development is over, we want to test the application, isn't it? Of course, to test the application, we have to have the final product in our hand. But how do I get it? To get this, we have to use different tools. The tools like Ant. I mean, again, gone are those days where we were using Ant. Of course, there are a few people, there are a few applications which are still using Ant. But again, we are not using Ant. The Ant was replaced by Maven. Maven Maybe you are familiar with it. It's one of the it's one of the building tool which was so famous. Nowadays it is kind of getting replaced by its competitor known as a Gradle. Gradle is very nice. I mean, if you are looking for Gradle, there are so many things which you can do other than the Maven. Gradle supports a language called it supports it's a DSL language. I mean, you can go ahead and you can literally write the program in the grid. Of course, by using Gradle, you can not only build your application, you can do various different things than Maven can do for you. And that's the reason why Gradle is getting its familiarity. Okay, if it is a building application or if it is a package you were looking for, the package is ready here. When I say package, again, please remember, for example, for Android, it is APK file, or for iOS, it is IPA file, or let's say, sorry, IPA file, or for example, if it is a website, then you are going to create the HTML file sort of it. When I say website, let's say I'm developing an Angular application, I'll create a build and then I'll create the HTML files or HTML version of it there. Now, once the application is built, once the package is over, probably you can simply go back and start testing the application. Now, of course, when you start testing the application, there are different type of tests. For example, when I say test, it can be a manual test or it can be an automated test. We decided that we want to go for maybe reducing the time, and we don't want to waste our time to do this manually, and that is the reason why we have to go for the automated test. If you want to go for automated test, there are again different kind of tests, something like the unit test, something like the UI test, then integration test, and so on and so forth. There are different tools available. For example, if you're developing a Java, you can go for JUnit. If you're developing a .NET, you can go for NUnit for unit test casing. If you want to go for a kind of UI test cases, you can go for Selenium, very famous. Okay, so probably when you talk about something like this, then probably you can think about getting those things or getting those test tools into pictures, which will give you a different type of testing in picture. For example, if you want to test the application's performance, there is another one, something called the JMeter. If you are developing a Android application and if you want to go for UI testing, then probably you may think about okay. So probably you may think about an application called as Appium, and there are various different applications out there which will help you to test the application. Once the application is tested well, probably you want that application to be delivered. So once the application is tested, hopefully we want to deliver the application. And when I say deliver, we have to release the application. But how will you do it? You have to do it automatically, isn't it? To do it automatically, there are different applications out there. One of the best applications, and believe me, I will say best because I know this tool and I love this tool, something called as the Jenkins. This is called as the Jenkins. This is the Jenkins which will allow you to execute all these stages one by one. See this, the developer has committed the message or committed the code. This is the commit. Then the the commit will automatically build the application by using different tools like what I mentioned earlier, Gradle, Maven, Ant, and so on and so forth. And the Selenium like tool, we are going to test it. But we want them to do automatically, isn't it? We have to do it automatically, but who will do this for us? This is called as a Jenkins or Bamboo, Atlassian Bamboo, or something called the Travis CI, called as CI tools. CI stands for continuous integration. We want to integrate these stages one after another like this. And if you want them to be automated, we need an application which will do this job. This job will be done by maybe a CI tool like Jenkins, like Bamboo, or like Travis CI. Of course, when as the application is released, it has to be deployed in some of the other machines. How do we do that? This has to be done by using different technologies, you can say. For example, you can go for something like the virtual machines, which can be automated by using a tool called as a Vagrant. Believe me and trust me, Vagrant is one of the most important tools in DevOps lifecycle where you can create all these virtual machines automatically just by writing the script. I mean, not only this, you with the help of Vagrant, you can directly create AWS resources as well. If your application requires maybe less resources, or if you want to go for horizontal scaling without wasting time in virtual machine creation, you want to prefer going with something called as a container, which can be delivered by something called as a Docker. And if you are dockerizing your application, if you are containerizing your application, then you need something called as a Kubernetes, which will manage thousands, millions of containers created by Docker. So this is generally called as the container orchestration tool. So there is a Docker, there is a Kubernetes, there is a Vagrant, VMware or VirtualBox like virtual machines where your application will be hosted or your application will be deployed. So tomorrow, if your application is getting too much of load, it will kind of create its own clone and make the application horizontally scalable. This can be done by using a tool like orchestrator tool called as a Kubernetes. Now, once the application is deployed, you want that application to be operated in some environment. And when I say you need to make that application operable, you need to configure your environment. How will you configure it? To configure it, we have to use different tools. Again, I'm talking about all these tools that will automate the flow. And if it can be done by using something called as a Puppet, or maybe something called as a Chef, or something called as Ansible, that will reduce the burden on the operations team. So if there are thousands of machines you want to configure, you don't have to go ahead and do it manually. Just use the Puppet and do it automatically. So when you ask Puppet server to do it, or just go ahead and install Java 8, if it is getting updated, just go ahead and install Java 8 on all the machines. It will do on its own. You don't have to worry about this. This is the job of Puppet, or this is the job of Chef or Ansible, whichever you want to go for. These tools are generally called as the infrastructure management tool, or it's called as the infrastructure automation. Infrastructure automation. This is the one which will give you should I say, hundreds or thousands of infrastructure automatically configured. You don't have to worry about that. Finally, we want to see what exactly is happening, whether the application is working, whether the application is behaving radically, whether the application is not getting the enough resources. That is generally called as a monitor, or monitoring the application. That can be done by using different tools like Splunk or Sensu or Nagios, or maybe you can go for something called as a Datadog. Again, I'm not saying these are the only tools you can go with. There are a bunch of other tools. All the tools which I'm mentioning here, most of them are free, but a few of them you may want to go for the professional licenses if you really want to. Otherwise, you simply can use the free versions of them. These are the tools which are very famous in those categories. Again, let us quickly see what are the different phases here. There is a plan, there is a code, there is a build, there is a test. We are testing the application. Here we are releasing the application, which is generally called as a continuous integration. Then we are going for the deployment. Then we are making the application operable in that environment. And then finally, we are monitoring the application to see what exactly is happening. This is all about the deployment, the DevOps lifecycle. You see that infinity symbol? Once the monitoring is over, we again are going back to the same plan, code, build, test, release, deploy, operate, monitor. Again, we are continuing this process till the end of the cycle. Fine. So this is what a DevOps lifecycle is all about. Let me just go through it quickly one more time and kind of summarize it. You see, there are different stages out there: the plan, code, build, test, integrate, then deploy, operate, and monitor. Now, generally, when you're talking about these stages, there are common terminologies we use here. And I bet you might have heard about them in the different part of the world because they are so famous these days. When you talk about the plan and code, most of the times, generally people refer them as continuous development. So basically, both of these stage, plan and the code, both of them are generally called as continuous development. When you talk about the building and testing the application, again, I'm trying to automate these things. And when I'm trying to automate these things, this thing will automatically go on or automatically do on its own. We don't have to worry about this. And if we are doing something like this is called as continuous testing. You see, there is something called as a continuous development. There is something called as a continuous testing. Continuous means it is going to happen continuously. Infinity symbol. Remember that. Now, once the testing is done, you want that tested application to get deployed by, integrating every single thing together. How do we do that? Of course, there we need the integration. So when we talk about this integration, you see, this is the test which is kind of getting integrated and kind of deployed right here. Now, when this thing happens continuously, this is generally called as continuous continuous integration. So this is called as the continuous integration. What is the continuous integration? Continuous integration is the process of getting all these, like maybe the code from Git or code from SVN, for example, getting it built, getting it tested, and finally deploying it to the right version or right stage. This is called as continuous integration. When you talk about continuous integration, right next to it, we want to deploy it. This is generally called as, both of them, generally called as continuous. All of them are the continuous processes. So this is continuous deployment. And finally, when you talk about monitoring your application, again, we have to do it continuously so that we can see whether there is any problem or whether there is a performance lag in our application. This is called as continuous monitoring. Okay, can you see that? This is where you can fit all the stages out there. Finally, once the monitoring is kind of done, or when you are in the monitoring phase, the developers will continue with planning the next phase. And again, we are talking about the same diagram here. This is the same infinity diagram I talked about earlier. But now we have we are kind of getting those common terminologies we use here. This is called as continuous development. This is called as a continuous testing. Generally, we use the short forms of that. CT, continuous testing. CI, continuous integration. Remember, a minute before I said that there is a tool called as a Jenkins, or there is a tool called as a Travis, and both of them are the CI tools. CI means it is a continuous integration. What's the job of a CI tool? The CI tool's job is to carry out all those stages one after another automatically or continuously. So continuous integration will kind of help you to achieve your goal without you bothering in or without you doing your manual intervention. That's the reason why CI tools are very famous. Now, once the CI tool has done the job, when you are having the tested application, well-tested application, you finally will deploy the application continuously. When one sprint is done, you want to deploy this application to the client. You will plan for the next sprint. By the time client will look for that particular change. And again, once you are done with this, you're again going to put the new release to the user. And again, you will continue back to your next sprint. This is going to happen continuously, continuous deployment. Finally, there is something called as a continuous monitoring, where you want to see whether the application is working properly or behaving properly. And that's what we said. There are many different tools here. For example, planning, there is there is something called as a Planio, or maybe Google Drive. There are many tools: Box, Trello, Atlassian Jira, so on and so forth. For coding, you can go for different IDEs, or you can go for different packaging tools and stuff like that. For building, you can go for Ant, you can go for something like a Maven, you can go for the best one, should I say, that's a Gradle. And once it is over, you want to test the application by using different applications, different tools like JUnit, NUnit, maybe something like the Selenium, TestNG, JMeter, and so on and so forth. You want that continuous integration to happen with the help of a tool like Jenkins, Travis CI, Bamboo. There are many different tools available. You want to deploy the application into different forms like virtual machine. You can go for Vagrant to create those machines, which can create, let's say, VirtualBox, or which can create the VMware, or which can create the AWS resources. You want them to get operated in that environment by continuously configuring them by using Puppet, Chef, and Ansible. And finally, you want to monitor the environment by using a tool like Nagios, Splunk, Datadog, and there are a bunch of other tools available. So these are the common terminologies. I bet you might have heard about them before, or you will hear maybe in upcoming days, because everyone is moving to the DevOps these days. Okay, so if I know the terminology, what can I do with it? See, even if you don't want to, sooner or later, you will realize that you have to go through this process. Sooner or later, you have to adopt yourself or adopt these technologies in your own day-to-day life. There is no escape from this. You have to do it. I know more, I hope you might have seen that as well, but I know many people are using those tools unknowingly, but they don't know they are doing the DevOps thing here. So basically, you are already following the DevOps culture because you are using those tools. So finally, if you want to, go ahead and look for a job for a DevOps engineer, what are the different skills you might go for, or what are the different responsibilities you need to carry? There are many responsibilities. I'm just trying to scratch the surface. You see here, of course, you have to be an excellent system admin because you are now a part of ops team, operations team. You have to be a system admin. At least you should know the basic understanding of a Linux. You should know the shell scripting and stuff like that. You need to know how to deploy the virtualization. Of course, there are tools out there which will help you to do that. Something like a Vagrant, for example, which will help you to create the virtual machines automatically. You have to have the experience, hands-on experience in the network and the storage. You cannot escape from the cloud these days. A cloud is nothing but the internet, or your cloud is nothing but the network of networks. So you can't escape from the networking. You have to know at least the basic part of the networking. Though you are not a complete developer, but being a DevOps engineer, you should know some kind of coding. Mainly, you should know some scripting languages. And when I say scripting languages, there are a bunch of them. There is a Perl, there is a Python, and there is a Bash script, and so on and so forth. At least you should know the basic scripting, the basic coding. Of course, you have to have the soft skill, of course. Then you need to know some automation tools so that you can automate these things, those which we already have discussed earlier. You don't need to be a tester, but at least you should know basic norms of testing. And finally, you should know the IT security so that you can secure the entire infrastructure. So being a DevOps engineer, you have to carry all these responsibilities on your shoulder every single day. If you want to do this, you have to have these kind of skills with you. Of course, these are the skills which every DevOps engineer must carry these days. For example, a DevOps engineer need to know these kind of tools. Maybe a kind of collection of tools like version control. There is one, maybe something like a Git or SVN. You decide. It's not a hard and fast that you have to go for Git or you have to go for SVN, but at least you should know one of them. For continuous integration, of course, you can go for Travis, you can go for maybe Bamboo. I would go for Jenkins because Jenkins is free. Again, it's used more or less in all the development these days, and that's why Jenkins. If you want to go for virtualization or containerization, you can go for Vagrant, you can go for Docker. And if you want to go for managing all those Docker containers, it's called as container orchestration, we need to go for something called as a Kubernetes. Of course, we want to manage our infrastructure. We want to automate that infrastructure creation. Of course, we need to know a Puppet or Chef or Ansible. Again, I'm not saying you have to know all of them. I'm saying like you need to know at least one of the tools in that category. And finally, if you want to go for monitoring, I can go for Nagios, or I can go for something like the Splunk. Now, other than the tools, you need to have the general networking skill which I mentioned earlier. You need to know why the connection is failed, or how to port to forward, or how to forward a port from one process to another process, one machine to another machine, stuff like that. And finally, other than that, again, I said earlier, you can't escape from cloud. So you have to have at least one of those cloud providers badge on your shoulder. So you need to know at least AWS or Azure or GCP, at least I'm saying. Other than that, you need to have the soft skills, which is kind of compulsory these days. And that's the most difficult job if you ask me. People management, you can manage the machines easily. They obey you, or they obey your instructions. Not about the people. You can't manage the people. That is a skill in its own. Not everyone is having that skill. But of course, when you're in DevOps, you need to manage the people out there. Okay, so these are the skills which you need to carry on, and these are the skills we need to have if you want to go back, if you want to go for a DevOps engineer. Now, if you're searching for a DevOps engineer, you might come across something like this kind of requirement. I'll just go for a couple of highlighted things here. You see, when you're looking for these kind of advertisements, you can see these people are looking for a DevOps engineer. Let me just show you here. These people are looking for senior DevOps engineer. Maybe in Hyderabad, for example, they did not disclose the salary, but I can bet on that if you're going for DevOps these days, you should get at least 5 lakhs to maybe sometimes, again, depending on your experience, 20 lakhs per annum. This is the range of the salary you are getting these days for a DevOps engineer. Believe me, that's a serious career right now. So this is maybe a kind of a career you should go for if you are looking for that kind of the salary these days. So what are they looking for? Can you just go back here? Let me just try to highlight few of them. You see, they're looking for the DevOps practices, which we already have mentioned earlier, where they are going to go for something like the CI/CD by using the Jenkins. Did I mention CI? CI stands for continuous integration. CD stands for continuous delivery or continuous deployment. There is a small difference between that. If you're interested, we'll talk about that sometimes later. Of course, we have to go for automation, virtualization, infrastructure as a code, metrics tracking, means basically you want to go for continuous monitoring, infrastructure as a code, meaning you have to go for Puppet, Chef, or Ansible. Virtualization means you have to go for a Vagrant, which automation, maybe the release automation. Again, it's kind of Jenkins, the Jenkins environment automation. So basically, whatever we have just talked about, they're looking for an engineer like this. Okay, so the person has to know the tools configuration and the different environments. So basically, you need to learn those tools. That's it. You see, I'm trying to highlight all those things. You can go for the Git. I mean, you should know the Git. You should know the Jenkins, and maybe the SonarQube, or maybe Artifactory, depending on which technology you are going for. As I said earlier, you should know at least the basic scripting like Perl, Python, Nant, Shell, PowerShell, depending on which operating system you are in right now. You should know at least one cloud platform. Maybe these people are looking for Azure, for example. They are looking for the Docker containers to containerize your application. They are looking for something like Kubernetes to orchestrate those containers. Maybe the service fabric, the Docker Swarm. If not the Kubernetes, you should know at least Docker Swarm and all these things out there. So probably when you think about something like this, or if you want to go for a career like this, there are many tools out there, isn't it? And you might be having a question in your mind. Maybe it's too difficult for me. Maybe I won't be able to learn all those tools or all those things at once. Okay, worry not, because we in SunBeam have launched a course especially for this. This is a DevOps course with SunBeam. So we are going to start that course on June 27. That's maybe the end of this month. And this will run through August 16. If you're interested, you can join us on every weekend, Saturday, Sunday, 7:30 to 11 p.m. We are going online. So this is the online course. The way we are doing it right now, this will be carried on a Zoom meeting. So everything will be online. There will be questions, answers. We will literally go that with live. So what are we going to see there? One of the source code management tools called as a Git, not the Git which you are using these days. I know everyone has this question. What are you going to learn there in the Git? Because we know Git. We are not going to talk about that Git which you know right now. I'm going to talk about the Git internals, how the Git works internally, what are the different objects it maintains, how the objects are getting hierarchy built internally, so that you will understand what is the branch, how to manage the branch, and stuff like that. That becomes a piece of cake if you understand the internals of Git, which is what we are going to talk here. As I said earlier, if you want to go for something like the virtual machines creation, we have to go for one of the tools like a Vagrant, which will create all those virtual machines for me. Of course, we have to build a pipeline, CI/CD pipeline, precisely by using a tool called as a Jenkins. Jenkins is very famous tool, and believe me, it is used almost in all the companies where they are going for CI/CD pipeline. It's very famous. It's just because it is developed by none other than Sun. Of course, Sun is not anymore as a separate company now. It's taken over by Oracle. Everyone might know that. So right now it is kind of owned by Oracle, but yeah, it is developed by Sun, and of course we can trust Sun. This is very, very simple and very kind of famous tool these days. Okay, we are going to go for continuous testing with the Selenium. Very simple tool again. We are going to use the containerization using Docker. Believe me, there are so many things to learn in Docker, which will help you to understand how Docker works, how Docker Swarm works, how to create the containers, how to manage the containers, how to create your Docker images, and stuff like that. If you want to create those containers, if there are thousands of containers, say you want to go for something kind of Docker Swarm, which will orchestrate those containers, which will manage those containers. But what if you are developing an application like Netflix, where they want to run millions of those containers? How do you do that? To do this, you can't go and trust with the Docker Swarm. We have to use a better tool called as a Kubernetes, which was backed by Google, which is still backed by the Google. And you know, Google will not back something which is not worthy of it. So when it is backed by Google, you can understand the power of it. It's very powerful. It's very simple to use. Sorry, my bad. It's not very simple to use, by the way. It's a bit difficult to use, and that's the reason why I'm here to help you out there. We're going to see how to configure our infrastructure by using both Puppet and Chef. Both of them are really popular in the market. And finally, we are going to continuously monitor our entire environment by using the Nagios. So this course, we are going to start at June 27. It will run till August 16. And this is the weekend course. Saturday, Sunday, 7:30 to 11. 11 is just what we are going to mention here. If time requires, we can go for 11:30 or 12, depending on the topics we are discussing. So this is all about this particular course here.